our 2 days faculty, Professor Raju Sarkar sir. He is from the Department of Civil Engineering, Delhi Technical University, and our additional director, Dr. Sanjay Bakchure sir. I welcome all of you in this 6 days training program on this surface and subsurface drainage management system. So today we are starting this online training program, and it will be concluded on Saturday, that is on 27th August 2022. In this training program, basically we have received various nominations from the um, state governments. In that, I want to highlight some states from which participants are nominated. Uh, One is Andhra Pradesh, Arunachal Pradesh, Assam, Chhattisgarh, Gujarat, Ministry of Road Transport and Highways, Mizoram, Meghalaya, Madhya Pradesh, Nagaland, Bihar, Tripura, Jammu and Kashmir, Uttarakhand, Uttar Pradesh, and Jammu Kashmir. In addition to these states or organization, we have also received nomination from the various PIU and RO offices from the DCL. In that, NHA DCL has nominated their officers from the Andaman and Nicobar Island, uh, from their office from the Assam, Sikkim, uh, from RO Jammu, from RO Srinagar, uh, from NHIDCL Arunachal Pradesh, also from the Ladakh NHIDCL, Nagaland, West Bengal division, Tripura division, and also from the headquarter monitoring division, and also from the Uttarakhand NHI DCL from the Uttarakhand. So we have received more than 160 nominations in this training program. So I expect from all the nominated officers that they will attend this 6 days training program. I think that this training program is very beneficial for the all the officers of various organizations, because due to the heavy rainfall, we also required proper drainage and subsurface drainage design in our payment. Keeping in view the requirement of the surface and subsurface drainage management, we have made various topics for which we think that these topics are very relevant for the participants. Today, there are two topics which we cover. First is requirement and overview of the drainage. Second one is the hydrological design of roadside drain. Tomorrow, we will discuss on the subsurface drainage and groundwater recharge. Then after, we will discuss on the sustainable stormwater management. On 25th, we will discuss on drainage of medians at grade intersections, high embankment, and bridge structure. In addition to this topic, we will also discuss on the drainage of hill roads also on 25th August. On Friday, that is on 26th, we will discuss on stormwater drainage system and appurtenance in urban areas. And on the final day of this training program, that is on 27th of August, we will discuss on the hydraulic design of road drainage. So we think that these topics will be dealt in detail to the participants. And due to this COVID-19 situation, we are conducting our training calendar as a online mode training program last 2 years. We expect that from next financial year, we are in position to conduct on this uh, in campus training program. However, till then, we are conducting all the calendar training program on this online mode of the training program. All of you know that on this online mode of the training program, we generally keep our lecture during the forenoon session only. So we will also keep our all the sessions in the forenoon from 10 o'clock to up to 1 p.m. on every day from Monday to Saturday. During this 3 hour session, there will also be a 15-minute time break at, at about 11 o'clock to 11:15 a.m. in the morning. I will request to the participant that please make it a two-way communication. Please ask the questions from our faculty, sir, and we expect from the participant that they will learn from this training program and try to implement all the things which they have learned during this training session. During this 3 hour session, we will also keep the question answer session at the end of the presentation on every day. However, during the presentation, if our faculty allow to the participant can also ask the questions from the faculty sir during the presentation also, and our faculty sir will also be happy to give the answer of all of your questions. And one another thing is also want to tell you that during this online mode of the training program, the attendance of the participants is must. For issuing the certificate, IHE has made a policy decision that we will issue the certificate to those only participants who secure minimum 75% attendance during the all the sessions. So during this 6 day session, all the participants are requested to attend minimum 4 sessions so that, or sorry, minimum 5 sessions to get the certificate for this training program. So I will not take much more time. I request our additional director, sir, Dr. Sanjay Bakchure, sir, to say few words to the participants. Thank
Uh,
you.
Thank you, Sunilji. Thank you very much for a brief review of the training program. Very good morning, friends. Very good morning, Sarkar
Good
sir,
morning,
today's
sir.
Good morning,
faculty
sir.
from the Delhi Technical University. Uh, it's my great pleasure to welcome engineers from the various organization. Majority of them are representing the North India, that is JNK, Himachal, Uttarakhand, then northeastern states, and many of them are from the NHIDCL, and there are few nominations from other states also. So friends, as you know that we have a very geographical and topographical vast area, and we have so many difficulties, and today's training program is very important from every aspect of road construction. We need to take into consideration these drainage aspects at the time of preparation of DPR. During the constructions, we face many difficulties, and also many of the problems we have to face every year because of the poor and insufficient drainage system, both surface and surface, because of which we find that all the rural roads and urban roads they face maintenance problems, right? So in that respect, this training program is a specialized training program. Already the brief, I think you have been given a schedule along with the faculties. And apart from this preparation of DPR, construction, maintenance, you see during the rainy season we face another problem of like a catastrophe because of the incessant rain in various parts of the country. And you might have read on TV and through newspaper or the other social media, even during the last month, so especially last fortnight, 2 weeks, we have lost many lives in Himachal Pradesh and northeastern states. So in all aspect, this training program will be very helpful. We have engaged the eminent faculties, expert faculties from the various organizations, and we hope that it will enrich your uh, expertise and experience, which will be very useful for you, all the engineers, for getting practical problem solved. As the Sunilji has rightly pointed out, please interact with the faculties. You can also share your own experiences. You can put your comments, suggestions, queries in chat box or during the tea break session or even at the end of the uh, everyday session, right? And make it interactive so that you will not get bored. And although a repetition, let me just remind you that this is only a 6 days training program, and we will be issuing certificate only for those participants who are attending 75% or more. That means you don't have any chance to lose the this initiation, right? So please be attentive, sincere, and attend all the sessions, not for the sake of certificate, but to enrich yourself of this training program of very important surface and subsurface drainage. With these few words, friends, I once again welcome you personally and on behalf of IHE for this 6 days online training program. I wish you all the best. Now I request today's faculty, Professor Raju Sarkar, for making his presentation. Over to you, sir. Thank you. Thank you.
Thank you, Sanjay sir. Thank you, Sunil sir. Just one correction, because both the time both of you have mentioned as Delhi Technical University is called not Delhi Technical University, it is called Delhi Technological University, and it is formerly Delhi College of Engineering. So I have put my correct email ID also, because email ID also wrong. It should be Raju Sarkar @ DCE, Delhi College of Engineering, not DEC. Delhi College of Engineering, let me say a few words about myself. That I'm Raju Sarkar, and I did my engineering from Northeast India. It is called Assam Engineering College. Basically, I'm from Assam, and I did my master's in geotechnical engineering, PhD in geotechnical engineering, then post PhD research in from University of Nottingham, United Kingdom, and I did my work in pavement geotechnology. I was there in the postdoc in Nottingham Transportation Engineering Center, where we mostly did the flexible pavement and the drainage system. So I'm really thankful that organizer has invited me to present some of the knowledge that I had, and to experience all the things with the participant. And I do feel that Participants will be enriched with my presentation. And as Sanjay sir repeatedly said, Sunil sir repeatedly said, if you feel any questions that you have some doubt, please ask in the chat box so that we can take up after my presentation, or in between there is a break. So break all during the break time also we can take up. Thank you, sir. Thanks a lot once again. And let me start that this is called requirement and overview of drainage. So I'm starting with, and here I have mentioned one group of also is called International Association of Seismology and Physics of the Earth Interior. Presently, I'm chair of the Commission and Outreach. So this is our topic: requirement and overview of drainage. So first is the confusion may come up, or that is rigid pavement and flexible pavement. Whenever we consider about any pavement, earlier it is only called the flexible pavement, because if we consider in a broader sense, to up or to change this flexible pavement in few places, we have started with the rigid pavement, though rigid pavement has been very new with compared to the flexible pavement. When we are considering about the flexible pavement, we generally consider the three layers. Mostly it's called subbase, base, and asphalt topping. Shortly it's called bituminous course. And if I'm considering rigid pavement, is called subbase and concrete. And below the subbase, please do remember we have another layer is called subgrade, which is the existing soil mass. So road drainage, the system which is designed for road for proper collection, removal and disposable of surface as well as surface water is called as road drainage. Please do remember that whether it is rigid pavement or flexible pavement, whenever there is a monsoon season is there, whenever water percolation, water starts to percolate through the pores available in the surface. If we are considering, if it is not properly bituminous course in case of flexible pavement, if in case of rigid pavement, if our top surface is not sealed enough, that is when no void should be there, so through which the water possibility of percolation is there. So if it is not there, the water will start to percolate throughout the subsurface. And if it is when considering about the subsurface, the problem will arise because those are nothing but without any binding materials. As a result, possibility of crack developing in the surface will always be there because uneven settlement will take place. So that is why the proper drainage system, without allowing any water to stable for a longer time in the road surface, we have to put our drainage system in such a way that whatever the water is coming up, it has to be drained out immediately to maintain the stability and durability of the road. As I told you in the very first sentence, that whenever monsoon season water starts to percolate throughout the top surface, what will happen? It will start to make a liquidify form, or it's called unstable in the subsurface area. So that is why the road drainage system will maintain as a stability and durability of the road surface and its foundation. And we have to keep this as dry as it possible, and we can do it only if we have the proper drainage system which can drain out all the water. This practice is only possible with proper and working road drainage system. Moreover, a good drainage of road helps to maintain the highway transportation with minimal cost, because if we do not have the proper road drainage system, what will happen? The top surface of the road starts to crack because of uneven settlement in the subsurface area. As a result, you have to go for the maintenance every year, and these will increase the cost of the maintenance. So that is why, to counteract it, we should have the proper road drainage system, so that the cost of the maintenance under your department should be minimal. Are you able to see this slide? This is called road drainage.
Yes, sir. Visible, sir.
Okay, thank you very much.
Yes, sir, visible.
Thank you. Next slide is that in continuation of the road drainage, the redirects water into appropriately designed channels, because in fact the subsurface, whatever the water is coming up, or the top surface, or whatever the water is coming up, it should be go to the channel, and then channel will in the proper channel wise, and it will go to the required level, because whenever there is low lying areas there, water will starts to assemble there, or you can say that it starts to gather there. So eventually discharges into natural water system, because wherever the natural water system is there, whatever the water is coming up from from the top surface, it has to go to that natural system. If I'm considering the water, because I do feel that since our participants are definitely all are the engineers, they have seen or they are associated with various organizations who deals with the road pavement. So definitely seeing the road surface, or which is called the surface water, which is called groundwater, I too feel that we should make the division also, like two types of water. Here I have put in the two category. One is surface water, and the causes of this surface water is either from rain or snow. Because please do remember, whenever there is a cold region is there, like Ladakh in India, we are considering about the Ladakh, or what is called Kargil area. You can, if you think about that, there interesting part is that during the summer, if there is some temperature changes is going on, if there, whatever the snow has been fallout, it starts to melt it down, and this melted down snow will try to percolate through the soil surface. So that is why whatever the water collected from the surface in the form of rain or snow, because these are main two sources, this is called the surface water, and the groundwater can be a problem when a water table is near surface. This is another problem because it's called groundwater. Why the problem is? Because if I'm considering groundwater table is near to the surface of the road, what will happen? It will start to collapse, it will still start to disturb the subgrade, there is the soil mass as well, because it will become the saturated condition. And whenever there is a saturated condition, if any load comes up, then it starts to undulate. So the change of the uneven settlement will be there. So that is why it's called that groundwater. Whenever there is groundwater near to the subsurface, or sorry, surface area, so it will create a problem in the root pavement. So again, another causes, that is the inadequate drainage. What will happen? Damage to highway structures, loss of capacity, visibility problems with spray, and loss of retroactivity, the safety problems, reduced friction, and hydroplaning. Because these are the, if there is a inadequate drainage system is there, so what will happen to the highway? Next is transverse slopes, because if I'm consider slopes, removable water from pavement surface, facilitated by cross-section elements, is called cross slope. Similarly, longitudinal slope. Please don't worry. I will share my slides with all of you in the PDF format, so that whatever the discussion we are having today, you are able to understand about whom we are talking. And in my presentation, there are many photographs also associated with. So I do feel that those photographs also will show you that what exactly we are talking about. So one is transverse slopes, another one is longitudinal slopes. Here, the minimum gradient of alignment to maintain adequate slope in longitudinal channels. Please do remember, one is transverse. Transverse means if I'm considering this is my road, so transverse will come this direction and longitudinal will come along the road. So longitudinal channels, ditches alongside of the road to collect surface water after runoff. This is what nothing but we are considering about that. If this is, might be you will be able to see my hands. So if this is the top surface of the road, whatever the channel is available next along with the road, those are nothing but the collecting water which have come from the surface of the road or the top surface of the road. So here some of the photographs, as I said you, I'll tell you so that it will be very easy to remember, or it is very easy to understand. This is called the transverse flow. And wherever there is water will percolate, water will come up in the form of rainfall or during monsoon, this transverse slope will help to go to the nearby area, and if there is any ditches are there, or you can say that the channel are there, natural channels or maybe man-made channels, it will go that road and immediately it will be collected. This is called transverse slope. This is So another one is longitudinal channel. That is the third one that we have considered in my slide. So this is called longitudinal channels. You see, in a one single section of the road, I tried to put the transverse slope, longitudinal slope, and the longitudinal channels. All 3 points that I have mentioned. So next is adverse impact of stagnant water on pavement course. Have a look on this photograph. This have a look on the photograph. This is one of the photographs that I collected during one of my visit in Melbourne in Australia in the year 2011-12. So have a look on it. What is going on? Actually, it is one type of hilly areas. So the water going on from up to down, then since it is little bit in a what is slopey ground, so water is crossing from one side to another side, and it is not agriculture. Forget about that. The foreign country in India also, if you go to the any hilly regions, you will find this type of that water is coming from one side slope to the another side in the transverse direction. You see, it is going on in the vertical direction along with the road alignment, because this is our road and it is going in the transverse direction. There is a 90-degree with this along with the road. So this is very disturbing one, because until and unless the stagnant water is there, and if it continues, that is what will happen. So that is why we are considering about in this slide and on, that is pavement courses, what will happen if the stagnant water is there. So effect of standing water or stagnant water on pavement. This is under the same heading, adverse impact of stagnant water. Consequence of standing water differs from pavement to pavement depending upon the type of surfacing provided. Please do remember, there are 2 points we are considering. One is flexible pavement, another one is rigid pavement. If I am considering the flexible pavement, as I said you, 4 courses are there, and in other way than in Indian standard or what is called IRC 37, based on IRC Indian Road Congress 37, we can consider it as a 5 layers also, including subgrade. One is subgrade, then subbase, then waterborne macadam, then dense bituminous macadam, DBM, and above it, bituminous course. So in this case, whatever we are considering right now, that if it is in the flexible pavement, since there is only one binding course in the top surface and the second surface, it is called bituminous course and dense bituminous course. And if the stagnant water is there, because water has the property, and it is the rule of the water, that it always goes towards the down surface. So whenever the stagnant water is there, it will try to find out the voids, and through which it will try to percolate through the it will go to the downgrade. I mean, I'm considering about it will try to go to the subgrade. So as a result, when it is percolating from top surface to the subgrade, it will try to disturb waterborne macadam, similarly subsurface as well as subgrade. That's why this is the main problem will arise in case of flexible pavement. And in the flexible pavement, any layer got disturbed, whatever I have considered, what is subgrade, what is subbase, or maybe WBM. So the whole structure of that layer of that road surface, flexible pavement, will start to settle down. In the differential settlement will take place. If I am considering rigid pavement also, because concrete also starts to pour some sort of water, if the concrete has not been done according to the requirement. Concreting not done because of the unskilled manpower, or maybe in some other reasons not properly compacted. If there is some void is there, water starts to percolate through these weak points. As a result, it will disturb the subgrade and one or subsurface as well as subgrade. So when they are disturbing these two elements or two these there, so automatically differential settlement will take place, and you will be able to see the horizontal cracks, vertical cracks, crocodile cracks, anything in the top surface of the pavements. Similarly, if I am considering flexible pavement, standing water remaining on bituminous pavement for a longer period of time is not desirable, as it tends to cause early deterioration of pavement. It is always, as I have discussed right now. So similarly, it can cause stripping of bitumen from aggregates, because bitumen and aggregate has its own bonding properties. But interestingly, if you put the whole bitumen and aggregate in a longer run to the water, or if you immerse in a water, you will find that their bonding will start to deteriorate. So it happens in case of stagnant water. In water, if it is stagnant water is considered the flexible pavement, it can cause stripping of bitumen from aggregates, especially when they are prone to stripping in case of some stones like granite, quartzite, quartz. So this works as a catalyst, because that time water will works as a catalyst and it starts to disintegrate in between aggregate as well as bitumen. So if the bituminous mix is open graded or poorly compacted or surfaces crack potholes, the water seeps to lower layers and accelerates the process of stripping, as I said you. Sometimes what happens, you have done all the work, you have gone for very good DBM layer requirement as per IRC 81, you have done all the design perfectly all right, and the DBM is done well, the BC course is done well, but sometimes due to repeated loading, and what happens is some sort of surface cracks will develop. And if in monsoon comes, that these or stagnant water is there, so this water stagnant water will try to percolate towards the down surface along with those cracks. So that way it will starts to create problem in that particular patch. Similarly, this water tends to migrate to lower layers of pavement and gets entrapped in granular base and subbase layer. Whatever I have discussed here, the point was I have mentioned it here. If the base and subbase layers are not permeable enough to drain away this water laterally, it results in pavement resting on a water bed, leading to loss of aggregate to aggregate contact, thus reducing load dispersal capacity and eventually leading to premature deterioration of pavement. Sometimes what happens, water percolates through a particular layer, later I am considering. And later on, since you have done very good compaction in case of subbase layer, so water is not able to get place to go down it. As a result, whatever the water is in the WBM layer, so it will work as a stagnant water in the whole, in case of the whole surface. And in that way, if I'm considering the whole cross section of that pavement or the flexible pavement, so this portion, this water will try to deteriorate. You see what is happening. It is the entrapped water. Neither it is allowing to go down because of the good compaction that you did in the subbase or maybe subgrade. And whatever the load is coming up every day over the top surface of bituminous course. So water is in between. If I'm considering this is the surface layer or the bituminous course where load is coming up because of the vehicular movement, and if I'm considering this is the subbase layer and all where they have done a very good compaction, as a result water is coming in this layer. So this water, when it is getting more and more pressure, it will try to go this side as well as that side also. So what will happen, that it will start to disturb the other layers or not other layers, other aggregates. So as a result, aggregate will lose its bond in between with bitumen, and it will start to deteriorate. So although bituminous pavement exhibits good skid resistance, but it does not rapidly help in rapid disposal of surface water. Please do remember. Because if I'm considering about any of the flexible pavement or bituminous pavement, you will find there are always undulations there, because you can't compact bitumen and the aggregate mix in a uniform way, because whatever the roller you are using, and it cannot compact in that way that it looks like a complete sealed. So definitely the surface will become like this only. You see aggregate, then bitumen aggregate. So whenever the continue percolation of water will be there or rainfall will be there, it will try to wash away in the top surface. This is due to the surface tension and also due to pitted surface without continuity, as in the case of textured surface of element concrete pavement. Because whatever I am considering that here in the first it is said, in the first point it is said, it does not rapidly help in rapid disposal of surface water, because whatever the water is there, it will try to stop up here. Just have a look after the rainfall, any road pavement. If you go ahead with that pavement, you just get down, starts to walk, you will find that below of your shoes or below of your if you are in the the barefoot, you will find that some sort of moisture is there. Why it is coming up? Because whatever the water has come up just after the monsoon or just after the rainfall, it has not gone away totally. It will not become dry. So that is another point, that this moisture starts to settle down whatever the lower surface is there, or you can say that lower portions are there in case of in itself is in the top surface. A typical edge bituminous surface where a layer of water takes more time to get cleared from road surface can be seen in this photo, because what I'm trying to say you that so due to the deterioration of the top surface or maybe repeated loading, so what is happening, the top surface of the bituminous course has been eroded little bit, and as a result whatever the water is coming up due to the rainfall or any reason, so this the water starts to settle down here. So as a result, this water will try to go down and it will disturb the nearby area. So let me consider about the types of road drainage now. First, I am considering about the surface drainage. It is the road drainage in which the surface water of the road is collected and disposable within right of way of the road. Because whatever the water is coming up from the surface, it has been collected. So it is called the surface drainage. Surface drainage is basically designed to prevent the flow of surface water to the soldiers, whatever the equipment we are considering, subgrade or any other layer of the road surface. Because our main intention is to prevent the flow of surface water to the soldiers. Because whatever we are putting in that barricade in between the cross section of the road, so it has to be it should not washed away, because these are nothing but the soldiers are nothing but the made by the what is called the soil, sometimes maybe by the concrete. So we should not allow it the water to go that side. Similarly, subgrade or any other layer of the surface, it may go below the subsurface or below the what is called the subbase also. So that's why it will disturb the subgrade. Because please do remember that this subgrade is completely made by the existing soil mass. No bonding on what is called, no binder has been used, neither cement, neither bitumen, nothing has been used. So existing virgin soil is called the subgrade, because what subgrade has been made, it is based on that virgin soil. Basic functions of surface drainage: the maintain to maintain the road surface completely dry from water. Similarly, to collect the drained of water from the road surface, we are continuing about the now basic function of surface drainage. Increase the stability of the road or highway, because whenever the surface is dry, so automatically the life of the road will increase. Similarly, by using the gravitational force, by using the gravitational force carrying of collected water into nearby stream or river or nala, because water has the rule, or you can say water has the property, it always flow along the gravity. So that is why what I'm going to say, that is whenever there is a high rise, lower is there, water will pass from high rise towards the lower rise. So that is why it's called that. The another main function of this surface drainage is to collect this water, and it has to be dispersed to the nearby stream or river or nala. So I'll show you the photographs also, because we are continuing right now surface drainage. So first one is I am continuing with the side gutter. Wow, how it is called the side gutter? Side gutters are generally constructed parallel to the side of the road, and it disposes the surface water efficiently. Because whatever the side gutter is there, the water it has to be constructed according along with the road, and another thing is that water is coming up. Its main work is to collect the water from the surface, which are coming up from the surface of the road, and it is dispersed to the low-lying area. And then I'll show you the figure, because that's why I written that below figure. Shows the side gutter or side drain in cutting and embankment provided for proper surface drainage. The section of side drain is generally trapezoidal, but generally triangular side gutters are also provided in cutting, because whenever we are considering about any side gutters, each sections may be in a trapezoidal section, but triangular section also can be used. So this is one that I try to put it here, because this is nothing but your side gutter. And whatever the water is coming up the road pavement with the because camber has to be provided so that we can get the slope, and whatever the water is coming up, it is collected in the side gutter, and the side gutter has its own slope also along the road, and whatever the water has been collected in the side gutter, it will disperse to the nearby stream. So the side gutter or side drain in cutting and embankment provided for proper surface drainage. This section side drain is generally trapezoidal, but generally triangular side gutters are also provided in cutting, as I said you. That is what we're considering. If instead of trapezoidal in section, have a look on it, this one, and the top surface is in the trapezoidal section. But sometimes it can go up to triangular section also like this, without giving in the trapezoidal. See, it is also work. So next is they are basically provided parallel to the road surface only when the designed depth of the side lane is less and the road is subjected to the light traffic. Because you see, in the previous slide, I tried to put it in the trapezoidal section. Let me go to this one. This is nothing but your triangular section of side gutter, because I tried to put it how the triangular section will be. And you know, the main purpose is in the side gutter, as I said you, that whatever the water has been collected from the surface, it will go to the side gutter and it will go to the low lying area. Sometimes
हेलो
what the ground level is so high with the
ये आ रही है आपको आवाज? हम काम कर रहे हैं, कोई मजाक कर रहे हैं?
Rupesh Kumar ji, your
तो मजाक चल रही
speaker
है
is on.
ड्रोन सर्वे
Rupesh Kumar
रिपोर्ट
ji,
10-15 दिन हो गए, अभी तक नहीं बनी है, क्यों?
Rupesh Kumar ji, your speaker is on, so it is getting disturbed to the presentation.
Mute, sir, mute.
Okay, thank you. So you see, if I'm considering about this section, sometimes what happens, the side soldiers or side area is lit. I'm considering two side hill is there, and our road is in between, because cutting the hills we have constructed the highway. So sometimes what happens, the water, whatever the water is coming from, just follow my arrow. So it is coming from this side. It has to be, because if I'm considering this side is very high, whatever the water will come during monsoon, it will come in a higher speed. So this higher speed would obstruct here, and it will come down directly here, and it may create problem to the surface of the road. During that time, if the vehicle movement is going on, so this water in a higher speed can create problem to the vehicular movement also. So in that case, you can put the intercepting drain or catch water drain. So intercepting drain may be there, because whatever the water is coming from the left side, it is similar in the right side also. You can put this one, and whatever the water has been collected, it can go to some other channels, or maybe the channel where the side gutter is going to join. But please do remember that all water has not reached to the side gutter. So the purpose of side gutter is, as I said, the collecting of the surface water only, of the road surface water only. So it will maintain that use. So that is a typical section that I have to put it here as a catch water drain. So similarly, functions of side gutter, as we know, but once again I try to repeat repeatedly. So that is the main function, is to collect the surface water, and further these side drains ultimately join the natural streams and nalla or rivers. So main function that they can be constructed and maintained in very low budget, but they give unpleasant look due to deep ditches. So you see, because whenever you are moving in a road, if the side gutter is there, so it doesn't look beautification, because you see the next left side, right side, so beautiful, the hilly areas, but suddenly you are finding the side gutters. It may aesthetically it may not looks good. So that is why it says that it may be an unpleasant look, as they are not adopted when the traffic is heavy. This is what we are considering about, because sometimes the purpose of side gutters may not be useful, because once the traffic is heavy, so there will be some thrust will come up from the horizontal in direction. It may affect to the side drains. So that is why sometimes whenever there's a traffic is very heavy in particular location, we need not to use, or it is not advisable to use the side gutter. So catch water drain, whatever we are considering about, first one was, please do remember, this is side water is known as catch water. As I said, you see, if I'm considering this side, the left side, is in the higher elevation with compared to the road. And our main intention is to keep the road in safe, or you can say that our road should be safe enough, so or in the dry condition enough, so that longevity of the road increases, as well as the vehicle movement will not be disturbed. Here, as I say, to catch water is coming from a high elevation, water come to the side gutter, and because although if water comes to the side gutter, what will happen? Overflow may be there, and this water level will increase up to this level, maybe sometimes. As a result, the surface of water or the road pavement will become very waterlogged. To counteract that, we need to go for this catch water drain, as I said you in my previous slide also. Just have a look on it. The velocity of water flow reduces due to catch water drain. You see, as I said you, when the water is coming from the higher end, and if there is no any catch water drain is there, what will be the speed of the water will increase, and as a result, it may disturb somewhere here, it will obstruct somewhere here. Similarly, it will try to go here also. So that is why I said, or we have put at this word, that velocity of water flow reduces due to catch water drain. So next is generally catch water drain is provided under following conditions, because there must be some terms and condition under which we have to consider this side water drain, or you can catch water drain. First one is when the adjoining ground is steep towards roadside. The first point that, or first factor that you need to consider, condition. In case of hill roads, when the rainfall is heavy, in case of hill roads, when the rainfall is heavy, please do remember, because rainfall is heavy, so automatically water will come more along the surface. So it has to be obstructed somewhere. So that is why case water drain. And third one, when the quantity of water flow on sloping ground is more. Because whenever there is rainfall is heavy, so automatically sloping ground water flow will be more. So functions of catch water drain. The catch water drain intercepts the large quantity of the surface water flow and also breaks the continuity of the flow. If I am considering again going back to this figure, because water is coming up, if there is no catch water drain, what will happen? The water will start to fall up to here. It will start from and it will end up here. So it will continue. So disturb that continuity, we have to put that catch water drain. And which reduces the velocity of water and prevents the erosion and landslides, and thereby protecting the road pavement. Because whenever the surface water from the higher land is coming in a very high speed, and when it stuck near to another soil layer, so it will try to erode. So that is why this prevention of erosion rules will come up due to this catch water drain. And because erosion is, when the erosion will increase, one time will come, it just starts to start for the landslide. So it can be protected that way. So catch water also helps in reducing the size of side gutter or side drain, because size of the side gutter is always there, but the thing is there to, if we do not have any catch water drain, what will happen? The side gutter area will increase, because all the water has to be dispersed through this side gutter in the absence of catch water drain. So another point that I like to put it here as a catch water drain is called sectional area of catch water drains are generally 0.9 meter by 0.9 meter and should be constructed normally at 4.5 meter from the road surface. Just some typical another photograph I tried to put it here, because we are considering the hilly road only. Unreinforced concrete machinery we are considering about here. So here we are considering that random rubble masonry, or you can say random stone masonry over here. So this is considered as a breast wall, because it is trying to protect the whole soil mass. Whatever the catch water drain is there, it is above that one, so water has been already obstructed in the continuity of the flow. Again, the side drain is there, because road pavement is there. Whatever the water is collected in the side drains, it will go below this water and it will go out of this whole wall. So this is the retaining wall, this is the ICR, this is the RCC parapet wall, this is the drain pipe we are considering as of now. I'll provide my presentation, so no worries for it. So it will go to you. So if surface water flowing from the high level ground towards the road is large, then it is desirable to take this water across the road at regular interval and then allow this water to flow through the pipe drain constructed through the road embankment in the natural stream. What it is trying to mention here, I try to tell you because every sentence I'm trying to discuss with you, that if your groundwater, or you can say that it is in the hilly area, and if it is in a longer route that you have to consider, so in that way, this type of crossroads or the cross drains has to be put in a regular interval, maybe after hardly 200 meter or maybe 100 meter, based on the location. Maybe after 50 meter also, because if the water is coming up in the higher ground, is very high in the case of monsoon. If I'm considering the places like heavy rainfall in Meghalaya area, similarly, if I'm considering the heavy rainfall in Uttarakhand, maybe Himachal Pradesh, in fact, in West Bengal, this is called Darjeeling area. So that time, this cross drainage is very, very useful because whatever we have considered as of now, so those are nothing but. Thank you, Sonam. Thanks a lot because it is a UCR facility. Because it's an course we are considering about that we are because we have not used any reinforcement also. That's why I said mention it as a unreinforced also. So whatever we are considering about this one, that if it is the water comes up in a very higher amounts. So in that case, from the left side to the lower side, or we are considering that if the higher ground to the lower ground, we have to put the regular interval of the cross drainage. So then again, surface drainage, a proper surface drainage system shapes and molds the land into a watershed that can convey the runoff into an organized drainage system comprising of trench drains, catch basins, and strong sewers. If the surface drainage is below par, it will have a dangerous impact on the subsurface drainage. And that is why this thing, whatever we considering, in after you can remember whatever we are talking about. So open drains can be of three types. Uh, this is one is the shallow. These are only up to 30 centimeter deep and can be created with the help of a hand shovel. Simple one. Then similarly, they help remove water from shallow depressions and direct them to a larger drain or a stream. These are not suited for draining a large area of land and are more in the shape of a temporary arrangement. Because whatever we are considering this drain, this is shallow drain, small amount. In fact, in our houses also, if there is water block is there, so what we consider, we take our hand shovel and starts to dig some of the soil so that water can go out. So this is nothing but we consider as a shallow drain. So medium depth, such drains are between 30 centimeter to a meter deep, and that created V shape. Generally, we consider these are the medium depth is V shaped, and I mean the triangular shape you can say it, and flat at the bottom, and a gradient that is steep enough to help water flow through quickly without damaging the drain walls or bottom. They are best suited for flat areas. As I said you earlier, we can have a trapezoidal section or triangular section also, but in this case we are considering medium depth, and medium is more suitable in case of the shape of the medium depth drain is more suitable in the form of triangular section. So this is the large open drains can be several meters deep and wide and are created with the help of dragline excavators, bulldozers, or scrappers, and are capable of evacuating large volumes of water. I took to put this what is called large drain. So with some beautification trees, because uh, these trees are not only increasing the beautification of the particular area, but also safeguarding people so that they get some alarm that yes, there is some obstruction, there may be some low-lying area is there where water body is there. So this way we are considering the large, or I put this photograph. So humps and hollows, this is another comes under surface drainage. This is a system where a surface is shaped into parallel humps and separated by hollows. You can have a look on it because you see There are some. It is mostly in case of cultivated areas. You can have a look on it. There is whatever the surface shallow is there, shallow water is coming up. Again, it is collected in these humps. So this is a system where a surface is shaped into parallel humps separated by hollows. This allows the hump shapes to shed excess moisture into the hollows, which double up as shallow surface drains. This type of surface drainage is ideal for areas where tile or mold drainage is not possible on account of inadequate depth or fall of soil. Because whenever we are considering for any side drain, so we have to have some own natural slopes also. But whenever there is no natural slope, in that case, this type of system can be used, and which are called the humps and hollows. So levees, this is another system where it considered mostly in the embankment areas. Levees are surface channel usually created on land with a gradient in such a manner that the soil removed to create this forms a levee in the downslope of the channels. Okay, this is two channels you can consider, or maybe that this is the only channel that is the cross section. So this is one type of levee where you have given their own slopes, and it is not only helping the disperse of water to a nearby cultivated area, but also it is helping to collect the water which are coming from the surface. I try to put it in a very, because this is a part of surface drainage. So I try to collect these photographs to show you that what is levees, because it may not be common in India, but there is another. This is also a part of surface drainage. That is why I put it this one. So other one is the grass waterways, where we generally consider about the grass and flexible grass in channels. We consider a grass water is typically quite shallow and maybe narrow to a few meters in width. Similarly, this can be used to regulate water outflows going down slopes so as to cheaply prevent erosion. Actually, our main intention of here, if there is any alluvial soils, which is called the sand or cohesionless soils are available, this because whenever there is water flow there, so it will starts to erode the soil mass, because those soil, cohesionless soil, or it's called sandy soil, they do not have the cohesion in between. So the whatever the individual water particle there, it may wash away with the water due to the sloppy ground. Because whenever there is any sloppy ground, there when cohesionless soil is there, it mostly happens in the hilly areas. So water is coming up from the top surface towards the low-lying area, so it is starts to erode. So it is always better to put this type of what is called filter strips or trap sediments, because it's a natural plant. You can say you can plant it also along with the surface. So it will try to prevent whatever the water is, whatever the soil is coming out with the water. So this is the natural system of blocking the soil eroded with the water. So this is grass to waterway, and whatever the waterway there, that the bed, because it is this water bed is also of the road. What will be the causes will impact in the surface so of the road. So this water, if it has gone out or gone down towards the subsurface as well as subgrade, that time, if there is possibilities there, that you can go for some sort of channels or small pipes, so that whatever the water has gone down, it can be immediately go out from that particular layers. So these whatever the water system is there, or the drainage system you have provided, is called the subsurface drainage. Means not in the surface, but below the surface. It may be in the subbase layer, it may be in subgrade layer also. If the moisture in the subsoil increases, it can weaken the root structure, because we have discussed about it many a times. So I do not want to repeat it again, because as we know, our main intention is to block the water so that it cannot go down, or it has to be stopped in the low-lying areas. Low-lying areas in the sense low-lying layers, which is called subgrade or surface. So if still water has percolated through it, so we have to collect those water immediately, because we should give the path, and those path is nothing but in case of surface drainage. So factors increasing the subsoil moisture content. What are the main factors? Because we are considering right now subgrade with the moisture. Increase in groundwater table, it also creates subsoil moisture. Water seepage from adjoining areas, surface water percolation through joints and cracks, rise of the moisture above groundwater table, which is caused by the capillary action. It is always very interesting to share with you that if there is any road is going on along the river bed or next to the river bed, because or maybe seashore area, or maybe any what is called lake is there. Along the lake, there is one road. You have to remember, whatever the subgrade soil is there, because soil has very interesting characteristic. It always absorbs the water, or that because of the capillary action, it always absorbs the water. So whenever the water is there, so this soil muscle starts to moist down. That is called saturated condition will come up. So under this heading, we are talking about the factors increasing the subsoil moisture. So this is why I say that rise of the moisture above groundwater table, which is caused due to the capillary action. Because as I said, the water has this, soil has this properties that it always absorbs the water. So there are longitudinal bituminous layer when the rise is subsurface. Whenever there is a possibility of water table is very low rise surface, and the water table is around 1.5 to the ground surface, the possibility is always there that remaining the 600 mm or 60 centimeter will try to come with the moisture. I mean, moisturize may be there, or maybe what is called saturated condition may be there. So that is why to counteract it, we can provide the impervious bituminous layer in between subgrade and the lower layer. So functions of subsurface drainage system, it prevents and control the moisture content of the rock subgrade, to maintain the bearing capacity of subgrade soil by restricting the entry of water into it, and to reduce the capillary rise, because sometimes due to capillary action the water rises into the subgrade from the groundwater and it starts to settle down in a different way. So longitudinal drains now we are considering under the subsurface drainage system, or sometimes called cross drains. The water table can be lowered by providing longitudinal drains and cross drains below the pavement structure at the specific depth. Longitudinal pipes are placed with open spotting each other, laid on a bed of stand cast stone of 150 mm thick. This is the size I have tried to put it up. This is nothing but your one type of cross drain that you can consider. You see, subsurface drainage system, because I'm not considering about the sizes and all, which are already there. Sorry. So here you see that because this is our subgrade, and below it, that if I'm considering about our water table and all is there, so it's always better to put some cross drains along with this one. So as a result, whatever the water may come down through this percolation system, it will be collected through the longitudinal system, longitudinal area. And similarly, if any lower groundwater table has increased up to this level, or maybe original groundwater table was there, so whatever the water is trying to possibilities there, it can increase later on due to the monsoon season. So that can be restricted with this longitudinal drain. So if I'm considering in the top view of this section, it will work like this way. This is longitudinal drains. Whatever the water is there, the top surface is collected. It is in the cross drain and it is of the longitudinal drain. Because our main intention is to lower the water table or groundwater table so that it cannot reach to the surface or the subgrade layer. So the diameter of cross drains varies from 60 to 100 mm. There are two cases of providing the longitudinal and cross drains. In first case, the main longitudinal drain pipes may be provided on both the sides as shown in figure, just I have shown that figure. In this case, slopes of cross drain is kept 1:50 from center to the side. This case of providing the L drains on both the sides is comparatively costly, but can be easily constructed and maintained. You see, we are considering about that cross drains as well as longitudinals also. And I tried to put, according to the mode specification, I tried to put some of the values also here. So like 1:50 or maybe diameter in between 60 to 100 mm. So this is another section I tried to put it here. So this is a little bit different with the previous one. You see, have a look on it, where we have considered that cross drainage in this direction along with the camber. Camber is this way, so we have considered this way. So here, just opposite, whatever the side drains or the water table possibility is there, that we are collecting here. So instead of two longitudinal drain pipes, here we are considering about the one longitudinal pipes only. And whatever the water is there, it has been collected here and it has gone this way. So next is, there are four main types of subsurface drainage systems. One is corrugated and PVC slotted subsurface pipes. Mold drainage, including mold drains over collector pipes and metal mold drains. I'll show you some of them. Interceptor drains and groundwater pumps, all considered in the subsurface drainage system. This is more of subsurface. What we have considered, now we are considering more system. On the PVC pipes is where percolation is there, percolation, and there's a gravel system is there, trench is there, whatever the water is coming up, water will go through the gravel, it will enter through this pipe. And the main purpose of putting the gravel so that whatever the water is carrying, the other foreign materials like sand and everything, it will come or it will obstruct here. The next I'm considering the another one is the mold drains. Our size is also mentioned here, there's 40 to 60 centimeter. I'm putting it as a millimeter, the same way. The success and longevity of mold drains is dependent on soils having a high clay content so that once a mold channel is formed, it will maintain the channel for many years. Mold drains are not suited to soils with clay types that have dispersive or slacking characteristics and permeable soils due to high sand or loam content. All together we are considering about these mold drains. So this is type of what is we're considering about the mold channels. This is water flow is there, then upward cracking, whatever. Because please do remember, whatever the water is coming to these perforated logs, or you can say it about the pipes, and it is coming in the natural way, because below the ground surface there may be some cracks are there. So these surrounding soil cracks are there, water is coming through those points, and it is collected accordingly. So these are the mold channels we are considering as of now. So then interceptor drains, the main purpose of interceptor is have a look on it, you see. This is the topsoil, permeable black is there. This is the interceptor drain, because that whatever the water is coming up, then it is also working as an interceptor, because this water table, okay, our main intention is not to allow the water table to rise. So to maintain that work, we can consider about the interceptor drain size drain also. These drains are installed at the base of slopes at the change of gradient, usually where a steeper slope meets the flats to intercept the downhill flow of surface water. Often the soil type on the slope is more permeable than those of the flats, and this forces the water to come to the surface usually at the change of slope. So whatever we have, the photograph which will say, whatever we have, I have mentioned it here, all it is showing in the photographs. So from concrete pavement point of view, because now we are considering flexible is over up, now we are considering about the concrete pavement point of view, because we have very little time before our first break. So I will go a little bit first about that. This concrete pavement point of view is a well-compacted concrete pavement is such a generally impervious to water and does not get affected by standing water, but joints, cracks, and soldier permit moisture to seep through. Why we used to consider that whenever there is any concrete construction or concrete pouring is going on, why we use the vibrator? Because main purpose of the vibrator is to reduce the voids which are available, and so that all the soil, all the the ingredients of the concrete can come closer with each other, and they should not have any pervious concrete. So to count to this one, since we are considering with the concrete pavement, so possibility of water percolation is near to the joints, because every time you can't construct a complete road of 1 kilometer without having any joints. So there must be some joints will come up. So similarly, nearby the joints, because joints are always the weaker point. So since there will be one gap in between the joints, so these joints will starts to erode down during the vehicular movement. So similarly, due to uneven settlement in the lower subgrade, so possibility of crack is also always there in the top. So in the soldiers area also, this moisture, because soldiers may be got cracked due to the what is called the change of the temperature or maybe other reasons. So as a result, this voids area or the cracking area will allow the water to go below the top surface. For example, a damaged joint as seen in photograph, I'll show you the photograph, permits moisture to infiltrate through. Moisture enters through all joints including longitudinal joints formed with the soldiers. See if I'm considering this is the one. You see, these are the joints. And as I said, due to the continued vehicular movement, there may be some settlement will take place here, another will maybe in the some other directions or maybe other places. So as a result, this corner of the joint starts to crack down. And once the cracks is there, whatever the water is there, it will try to percolate through it. Similarly, this is another corner joints. Have a look on it, because this is the the one animation photo is there. So along with the actual photo, I try to put it out. A damaged joint group can permit seepage of water to the lower layers always. So again, the granular or earthen surface, standing water on granular or earthen surface is not desirable as it seeps the lower layers. Earthen surface becomes slurry, making them unusual. Cross slope of soldier provided should be steeper so that water can flow expeditiously on such surfaces. Requirement of cross slope in earthen soldier thereby always has to be more than the paved surface. Ladies and gentlemen, I'd like to share one thing that no doubt some of the slides I try to make in such a way that if once you read it, you will be uh, able to know what exactly I'm trying to say you. Since it is in the online mode, so sometimes it is very difficult to show you many things, whatever in the physical mode. So that is why I made my presentation in such a way that if you read the sentences, it will be enough to understand what exactly we are talking about. And here we are considering, first we have considered our surface as a bituminous surface. Next we have considered about the concrete surface. Now we are considering about the earthen surface. Sometimes the earthen surface mainly in the village roads, maybe the nearby roads. If you are from the village, you have seen this type of road. So we are considering right now the granular or earthen surface. Requirement of cross slope is always there, so that because if the earthen surface is also or earthen road is also there, so that time also we must maintain some sort of slope so that if the water comes, it can go to the sides. So drainage consideration for roads in rural sections and urban sections, I try to put both. So here, so design of road drainage system, drainage is a basic consideration in the establishment of the road. In the road geometry, the crossfall should be of minimum of 2.5% in case of carriageway, and similarly, crossfalls up to 5% on hard soldiers draining to filter drains. The longitudinal gradient should not be less than 0.5% in case of curved roads. So similarly, flat areas should be avoided, and considerable consideration of surface water drainage is particularly important at rollovers, roundabouts, and junctions. Outfall levels must be achievable. The spacing of road gullies should be sufficient to remove surface water whilst achieving an acceptable width of channel flows. So similarly, overall drainage system for variable loads, I am not going to read it out because the table itself is saying many things. We are considering of the urban roads, we are considering the major rural roads, then minor rural roads, then similarly its curves and gullies, then combined curve, then linear drainage, so open drains, all the things that we mentioned. Just is go through this table. So recommended design selection for urban road. If you consider the urban road, it may be no groundwater problem. If there is groundwater table problem, then if it is groundwater table problem, then we have to go for a combined filter drain. And if I am considering no groundwater problem is there, then the silk carrier pipe will be enough to consider this one. So again, road in cutting. We are considering right now the rural road drainage. Road in cutting and the road in embankment. Similarly, if it is less than 1 meter drain from carrierway, maybe drain is more than 1 meter. Then in case of also again the combined filter drain should be there. Combined filter drain here also should be there. Based on the difference, I tried to mention it here. So about the edge drainage, it is the best one that if I am considering about the road on embankment. So similarly, if I am considering about the sealed carrier pipe, here it is because this is also useful where whatever that layer is considered, we have to put in the sealed carrier pipe has been given up. So whatever the water has been collected or what will go, it will cross over through this one. So combined filter drain is this one. I tried to put it here. So inflow is there. So our main intention not to erode the surface one, and we are considering as of now as a earthen road or maybe bituminous road or maybe concrete road because we are considering now the subgrade area. So similarly, requirement of drains for road embankment, what are the requirements are required? Requirements are considered in case of drains. For roads and embankment, the side drains are provided on one or both sides. Similar side drains are constructed at a minimum distance of about 2 meters from the edge of embankment so that the water flowing in the drain does not enter the earthwork because our main intention, whatever we are considering till now, the same thing. And please remember, this is metallic road means either bituminous or maybe concrete. So these drains are also useful in resisting the rainwater falling on the adjacent land parallel to the road, and it is does not allow to reach the embankment. The water flowing in the side drain can then be suitably disposed of without causing any harm to the roadway. As I said, you some of the slides you may find that we have already discussed about it, but still I have put this one because all slides are interconnected with each other. So in case of in cutting area, just have a look on it because it is the original slope of the ground. So you have cut it out, and this is mostly in the hilly areas. You can have a look on it. The for roads in cutting, the side drains are provided on either side of the formation. It may be here also. It may be here also. These drains are carefully designed, and it is to be seen that they do not overflow under any circumstances, and making the roadway submerged in water. Okay, this is the main intention because our main that is our carrier's way or the top surface should not be below the water level in any case. So again, the open deep side drains may prove to be dangerous and unsightly, specifically in cases where there is a restrictions of space. In such circumstances, the covered drains or pipe drains or ditches filled properly with suitable materials like coarse sand and gravel may be provided to arrest the pipe or whatever that we have considered the mean through which the water will go out. So this is a typical photograph, that road with hill on one side and the valley on the other side. Just have a look on this photograph. When a road passes through a hill terrain, it has usually hill on one side and the valley on the other side. So in that case, please do remember that it also gives the longitudinal direction of the drain also will be there due to the nature. So similarly, some sort of scours checks must be provided, cut off so that whatever the water is coming up, it can be obstructed in lateral direction as well as longitudinal direction in the both the cases. And mostly in the hilly areas, we get the natural slopes, so that's why we have to counteract that natural slope also. We have to take the advantage of the natural slope as well as we have to disturb the natural slope also to obstruct the loss of the highway in any cause. So this is another one that runoff coming from the hillside must be intercepted by providing a ditch at the foot of the hill and disposed of in the valley side by providing drainage culverts at suitable intervals. If drainage is not adequate, the runoff water will flow above the road surface and resulting in damage. This type of photograph I showed in the earlier also, now also I'm saying that if you think about this road and it is submerged the water and I can see, I can discuss because I'm, as I say to in the northeast part of India, mostly Assam flood is quite common in every year, and definitely our friends who are representing the various states, they or various organs, they also face this type of problems. So our if there is any road is submerged below the water, the problem will arise because not only from the road construction point of view, or from the other is the vehicular movement point of view also, because if there is flood water is there, so no vehicular movement will be there. Why? Because whatever the vehicular movement will be there, the load will come. Already the water surface, road surface as well as the whatever the layers are available, whether it's subgrade, subbase, all water will be there because it is in the submerged condition. So this vertical load, which is coming along with the due to the movement of the vehicle, it will destroy more because the surface of subgrade as a subbase, they are in the weaker in section or weaker it will be. So as a result, it will settle down immediately. So that is why it is always safer side not to drive if you find this type of road. So often debris and stones fall into the drain, blocking it and causing overflow of the drain and road, because it mostly happens in the flat areas, also hilly areas, because the water always carries some sort of debris as the stones also, it blocks the drains. So there is a proper maintenance of the drain is always required. The drains are lined with concrete or stone masonry to avoid erosion, since the longitudinal slope of drain is quite high and rolling stones cause high friction, because when the stone is coming from the higher side to the lower side with the rolling mass, because in the rolling direction, so what will happen is still it stuck directly to the soil mass, it may create some sort of erosion also. So counteract it, it is always useful that your side drains on the longitudinal drain should be the stone masonry or maybe with the concrete. The spacing of the culverts is governed by the rainfall intensity, width of drain, and contributing to runoff, slope of the ditches, etc. All comes up in accordingly. So that is why some of the points that whatever we have discussed till now, it is based on the specific condition of that particular state or particular area. Also, it works that way. So this is the before concluding my presentation of this one, I try to put this damage to a road surface due to inadequate drainage. Sorry, I forgot. I mean, type it mistake due to inadequate drainage. You see, have a look on it because no proper drainage was there. So as a result, water logging, you have seen it. Similarly, here also some sort of cracks developed, so surface is completely moist. Here also, along with the road, many cracks has been developed because of the water logging problem. So thus, I would like to conclude my presentation. Thank you very much. So if you have any query, please feel free, because I would like to go to some of, yes, Thayo Mog, you have mentioned about the UCR masonry, and I am really thankful to Sonam. He has mentioned, replied correctly that Ankor's random stone or random rubble masonry also it considered. So thank you, and feel free because we have some few minutes, and then I will go for a 15 minutes break. And am I right that there will be a 15 minutes break in between?
Yes, sir. Yes, sir.
Okay, thank you. Or if you do not have any question as of now, it is not coming up, so you can write them in the chat box. We'll take up again just after 15 minutes. We'll assemble here at 11:30.
Okay, sir.
Thank you.
Thank you, sir.
Very short break of 15 minutes. Since we have to complete our presentation as well as discussion as per our stipulated time, so we are come back at 11:31 instead of 11:30. So Gurpreet, are you there? I'm seeing that you have mentioned one question.
Yes, sir. I am here, sir.
Okay, Gurpreet, please unmute you. Mute yourself because some echo is coming up. Thank you, Gurpreet. So you have mentioned that to all of you, because all of you are able to see in the chat room. Group it has written that, sir, as you say, there is certain issues raised like settlement of road, etc. Near the surface. So what is the solution of this problem and how to overcome and enhance durability of road? Gurpreet, if you go through my last 5 slides, 5 to 6 slides, I've given two systems. One is the drainage pipe system, where possibility is there to lower the groundwater table. Repeatedly, I was saying about it in my presentation. And another one that
Sir, slides are not visible, sir.
no, I have not shared any
Okay.
slide till now.
Okay,
I'm
sir.
considering about the last presentation slides because I have to share with our participants.
Okay, sir. Okay.
Because I'm taking up the questions so that we can have the discussion on it. And in our next phase of presentation, we have little slides. I mean, not that much as it was, but around 6 to 7 slides less with compared to the session one. So that's why we are talking about our questions. So Gurpreet, another problem in case of groundwater table is very near is that before construction, starting the construction of the road, you have to seal in the sense you have to put one layer of impervious layer either with the concrete or maybe bitumen, and mostly there are many epoxies are available, and where we have to go for that systems where you can put one layer of thickness around not more than around 2 centimeter or maybe in between 1 centimeter or 2 centimeter of the bituminous layer, where it will reduce the percolation of water from the groundwater table. It is whatever I am considering as of now, it is below the subgrade. Now, if I am considering because possibly the water also comes through the side drain, or sorry, side areas also. So in that case also the same system you can put in the other sides or the sides of the roads also, where because whenever I'm considering about the road, it is always trapezoidal in section, the reverse of the trapezoidal section. So that way, also this type of impervious layer will help you to reduce or the percolate the water due to the groundwater table. So this is one system, but please do remember that wherever there is groundwater table is very near to the surface where the road construction there, cost of construction is always high, because you have to take care of the water which is not acceptable in anyhow, because whenever there is any water body is there or maybe water, the rainfall, everything, this water is the main enemy of any road. Please do remember. So that is why we need to talk or we need to think about, and because in fact not only in this case, if I'm considering some places where the water may not be there, but the what is called black cotton soil or that what is called soft soils are available. In that case also, expansive soil, this is another name, might be black cotton soil, expansive soil, maybe soft soil. So there you know that that expansive in nature, so if there is any water is percolated through the ground surface, so this subgrade soil will starts to burst down, when it will expand. Similarly, during dry season it will contract. So this is another soil layers may be possible where you have to go for the road construction, but the cost of construction is always high. So in case of whatever the question you are, that is next to the groundwater table, the road. Similarly, in the expensive soil case also. So we have to, since we are in this business of road construction, so we have to consider all the things. And I can understand that if all of you are from the organizations who are dealing with the pavement structure, so that's why we can't have the alternate road or alternate surface where you can get a more and more better type of soil. But we have to come across this type of systems or this type of problems. So thank you, Gurpreet. I do feel that I have tried to clear all of you. And if you have any more questions, we may discuss or you guys send those questions in our chat room just after the presentation or during the presentation itself. So now I'm sharing on my next slide. Are you able to see my presentation?
No, sir. Starting, sir.
Okay, just a minute. Let me see once again.
Yes, sir. Visible, sir. Visible.
Oh, it has gone actually. You said no, so that's why. Okay, wait, once again, once again. I'm keeping it up.
Yes, sir. Visible, sir.
Okay, thank you. Thanks a lot. So now, this part of the section, we are talking about hydrological design of roadside drains. Here, we like to consider about mostly the side drains, and it may be trapezoidal, it may be a triangular in section. So, is my slides are moving? Are you able to see my second
Yes,
slide?
sir. Yes, sir. Yes, sir.
Okay, thank you, thank you. So, objective for design of roadside drain to determine the catchment area and the expected flow, to collect design information for drainage system, to determination of runoff onto the road and discharge of water, to design of the drainage channels using results obtained. The main objective of design of roadside drains, once again I am repeating, so that we can come to know about the catchment area, size of the catchment area from where the water possibility is there, and the expected flow, how much flow will be there during monsoon or maybe in the other season, pre-monsoon, definitely pre-monsoon not there, but sometimes sabbatical monsoon, sabbatical rainfall is also there. To collect design information for drainage system. Similarly, in the design information, in the sense nearby area, is there any other natural drainage system also there, or maybe some low-lying area is there where possibility of water collection maybe. So these type of things. Then to determine of runoff onto the road and discharge of water, and to design of the drainage channels using results of whatever result we have got it. Based on that, we can go for the design of drainage channels. So surface drainage system design trade-offs. Steep slopes provide good hydraulic capacity and lower cost, but reduce safety and increase erosion and maintenance cost. And our main purpose of this drainage system design. Then three phases are always there. That is estimate of the quantity of water to reach the system. Then hydraulic design of system element. Then comparison of different materials that serve same purpose. Because these phases has to be considered before going for the surface drainage system design. So forms of precipitation, because we must know about it, what type of precipitation the water possibility is there. One is rain. We know in the monsoon we used to get the rain. So water drops that have a diameter of at least 0.5 mm. So light rain consider up to 2.5 millimeter per hour. Moderate rain 2.5 millimeter per hour to 7.5 millimeter per hour. Then heavy rain is always more than 7.5 mm per hour. Then similarly snow, as I said you, that precipitation in the form of ice crystals which usually combine to form flakes with an average density of 0.1 gram per centimeter cube. Just I'd like to mention here that in cold regions, during monsoon, if the water percolates through the surface of the road, it will try to pass through all the layers up to the substrate. So during this percolation, it doesn't mean that it will take place within 1 hour. It may take place after 3-4 months also, or maybe some sort of soils are there. It can withhold, or it can obstruct the water passes also. In that case, let I'm considering that uh, cold season has come up. This means winter has come up, and it is in I'm considering the places like Ladakh or any other places, Jammu and Kashmir or that way. So what will happen? This water will settle down in the form of ice. And please do remember, we know that volume of ice is always more than volume of water. So that is why if the water has been stuck up in between top layer and the bottom layer of any road, so what will happen? This increase of volume due to the formation of ice from the water will create some sort of cracks, or it will develop some sort of cracks in between the top layer and the bottom layer. So as a result, you will find unacceptable condition of the or unacceptable form of the cracks that has been developed maybe in the subsurface or maybe in between. So that is why snow is one type of precipitation we are considering about. The drizzle, rain droplets which are less than 0.5 mm and intensity is less than 1 millimeter per hour is known as drizzle, because I tried to put it all the differences also, forms of precipitation. Similarly, glaze, when rain or drizzle touches ground at 0 degree centigrade, glaze or freezing rain is formed. Similarly, sleet, it is frozen raindrops of transparent grains which form when rain falls through air at sub-freezing temperature. Then hail is one type of, hailstorm. That's whenever we used to call in Hindi is called ole girna. So that is what hail is always there. It is a shower precipitation in the form of irregular pellets or lumps of ice of size more than 8 mm. Because hailstorm is another point which is a source of water in case of precipitation. So rainfall measurement, because we must know about the, whenever we are considering the rainfall, we must know about that measurement system. Non-recording system, it is called Simon's gauge. Another one is recording system. It is maybe tipping bucket system, weighing bucket system, and natural siphon system. And out of all this, tipping bucket system is quite common. This is a typical Simon gauge, how much water has been percolated through this funnel uh, after a particular time. That much of water will be considered as a precipitation per hour. So this way it considered. So similarly, this is one type of rain gauge where some sort of containers or some sort of systems are there. And this measuring jar will help you. So how much water has been percolated, so how much water has been fall up, or the rainfall has been taken up within that 1 hour, maybe 2 hour, maybe whole day. So then recording rain gauges, as I consider, this is the instrument, records the graphical variation of the rainfall, the total collected quantity in a certain time interval, and the intensity of the rainfall. It allows continuous measurement of the rainfall. And please do remember, when I'm considering about the recording rain gauges, it is always a millimeter per hour. Then tipping bucket system, this is one two type of tipping bucket. Whenever there is waterfall comes up, it goes this way, maybe right side, maybe lower left side, this way. The number of tipping is taking place. There is one recorder will be there. It will tell you the how much tipping has been come up. So it will collect the water in the measuring glass or measuring jar, and it will also show you the same system, which is quite common these days, and it will record in electronically about this number of, or that amount of water that has been collected within a certain time frame, maybe 1 hour, because it is, you see, if you have collected the water for 3 hours and this much of centimeter of the height of water you have received, so that convert that centimeter to millimeter and divided by number of hours, it will give you the millimeter per hour. It is nothing but the average value. It will tell you. So next is weighing bucket system, the same system where you have to, where one pencil is recording pen is there, and it will increase where as and when the water has been collected here. So some sort of mark will be mentioned in this graph paper, and there also you can find out how much water before the measurement starts, and what is the the length that has been made by this recording pen after a certain time. So it is nothing but a weighing bucket system. As I mentioned, the instrument gives a plot of cumulative rainfall against time, so mass curve or rainfall. So next is natural siphon system. This is one type of float type. These are the system that I am considering or that we are discussing right now. The rainfall collected in the funnel shape collector is laid into a float chamber, causing the float to rise. As the float rises, a pin attached to the float through a lever system records the rainfall on a rotating drum driven by a clockwork mechanism. A siphon arrangement emphasizes the load chamber when the float has reaches a present maximum level. The system is very simple. But the out of all this, why this is quite common, this tipping bucket system, because it has record directly how much water drops has been collected through this funnel, and it has gone up to the measuring glass. And it do not require any skilled maintenance or what's called skilled person. Just one thing is required, that if you are collecting after every 1 hour, so you have to collect the water just after 1 hour. If it goes beyond 1 hour, so you may not get the accurate result per hour. So that is the one thing that you need to consider. So presentation of rainfall data is always, it is called hyetograph. Probably since all of you are engineers and you think about your undergraduate days when we are talking about unit hydrograph. So hydrology chapter were there. So we have collected all this related drainage system from there only. It is called hyetograph. It is the plot in between rainfall intensity with respect to hours. If I'm considering this graph or this hyetograph, this shows that in between 1, 2, 3, 4, 5, 6, yes, in between 6 to 7 hours, in the sense what is called morning 6 to 7, 1 hour, the water rainfall intensity was around 182 or 184 millimeter. So, though what is considered that you can take all the average value divided by the number of hours, or another one is that that in a particular hour of the whole 24 hours, what is the rainfall intensity? You can say that morning 6 to 7 we have received 182 millimeter of rainfall. So similarly, if someone asking you the how much rainfall you have got at night from 8 to 9, so in that way you can say from this graph that is hardly 20 millimeter. So mass curve of rainfall is another system where cumulative rainfall is collected, and from there also you can find out that how much water has been poured down due to the rainfall in a particular time or particular time frame. The point rainfall, it is also known as station rainfall. This is what, wherever you are putting the rain gauges in a particular point, how much water you have collected or the rainfall you have collected during the monsoon, so or maybe in any rainy day. So this is called point rainfall. That in a particular rain gauge you have collected some sort of water. If I am considering in your place, like in your city, so you cannot say that if someone is asking, like I am considering you were in Mumbai, if someone is asking how much water penetration was there, or sorry, penetration of water, or maybe you can say that precipitation of water in a particular time or particular day was there. So in enter Mumbai, there may be various. I mean, the number of rain gauges will may be there, and collecting all the data, you can say, oh, in this particular area we have got little rainfall. In this particular area we have got the more rainfall. So, because whatever the collection it is there, it is based on the rain gauges of a particular point. So, similarly, in case of point rainfall, whatever your rain gauge has been collected in a particular point or particular what is called the area, or maybe a societal area, a small area. So, that can be considered as a point rainfall, and which may be differ with the average rainfall. Definitely, it will differ from the average rainfall, as well as the maximum rainfall and minimum rainfall in the same particular day, in the same particular hour. Sometimes we used to consider, right? You used to talk, okay, how much water you have got, or how is the rainfall in your place, which is a very heavy rainfall from 8 to 9. Similarly, other, no, it's a drizzling only, small, I mean, that small quantity of rainfall was there. So these way, those water which has been considered based on some measurement, we are considering about the point rainfall. So mean precipitation over an area, because if these are points are the rainfall of these rain gauges, and if you want to determine that particular area how much precipitation is there, so there are a few methods. One is arithmetic mean method, another one is Thiessen polygon method, isohytal method, then inverse distance weighing, and in consideration of arithmetic mean method is very simple. It is the average of number of rainfall, the water that you have collected, or that what is called rainfall you have recorded. So it is summation of pi divided by n, which is pi is I equal to start from one number of rain gauge towards the number of rain gauges. So rainfall at the ith rain gauge station to the total number of rain gauge stations. So Thiessen polygon method, this method assumes that any point in the watershed receives the same amount of rainfall as that measured at the nearest rain gauge station. Here rainfall recorded at a gauge can be applied to any point at a distance halfway to the next station in any direction. So this is the Thiessen polygon system. I'll tell you about in the diagram also. The draw lines at joining adjoining gauges, then here we consider the area as well. To the value. Similarly, this is called isohyetal method, where a what is called some sort of line where you can say the contour maps showing the 10 mm water precipitation. Similarly, 20 mm water precipitation. I mean the rainfall. Similarly, 30 mm water rainfall. All can be collected, or you can consider as a map, which is a contour map, which is joining the place. It's called tutorial class, so I'm not considering any type of numerical as of now, but I try to give you some example of how to determine that the amount of rainfall in a particular area. So this is one that is a network system where you have to consider polygon uh, amount of. So other one is inverse distance weighing IDW. Prediction the point is more influence measurements than that of a distance measurement. So here some of the systems are there, some of the equations are there. I don't want to discuss about these equations. So just I put all these formulas here so that it will be easy to how these have been considered. This is distances also mentioned D1 in that particular rain gauge. So based on that average, we can find it out. And where we have considered the direction, or that what is called that x1 and y1, this is the coordinates you have pointed out, and what is the distance of that one. Based on that, we have got this value. So here another one, that is adjustment of precipitation data. Sometimes what happens that whatever the value you have got, it may not be correct, because let I am considering a particular location, you have 20 rain gauges. But suddenly, out of 20, 18 were correct. Are you able to hear my voice?
Yes, sir.
Yes, sir.
Okay, please respond immediately. I was thinking that because some network problem is showing up, so that's why I tried to put it here. So adjustment of precipitation data now, because as I said you that there are 20 rain causes are there, out of 20, 18 are also only working, 2 are not working. In that case, what we will do? So this is the what called adjustment of the precipitation data, because we can't leave that particular area also, because we have to collect that rainfall or the value. So that's what we are considering. The normal rainfall as standard of comparison, the normal rainfall is nothing but the average value of rainfall at a particular date, month, or a year of a specific 30-year period. That I am considering check for continuity estimation of meshing data. Annual precipitation at neighboring M stations 1 to 3 up to M. Missing annual precipitation rate I am considering PX, and is the normal annual precipitation at all M stations, M number of stations. So in that case, so in this adjustment, we can go for the arithmetic average method, maybe normal ratio method also. Why when I'll go the arithmetic average method, this method is used when normal annual precipitation at various stations show variation within 10% with respect to the station X. Similarly, when normal precipitation at various stations show variation is more than 10% with respect to station X. So adjustment, continuation, test of consistency, causes of inconsistency, shifting of rain gauge to a new location. It is quite common here. Because sometimes what happens, later I'm considering our stations is wherever you are standing or wherever you are sitting and hearing us or hearing me or you are attending this training program, let one rain gauge is next to you. But due to some changes or due to some displacement of your location, you have to shift this rain gauge. So in that case, possibility of getting inconsistence of the records always there, because shifting itself it may take time. Again, you have to think about the where to shift and prefix location. Then please do remember, in case of any rain gauges, area that rain gauge can cover is up to a diameter of 3 kilometer only. So it is within the 3 kilometer. If you do not have any another rain gauge, it's okay. But beyond the 3 kilometer radius, you have to go for another rain gauge, which will cover next 3 kilometers of the radius. So let I'm considering that these three rain gauges, the new rain gauges come up. So you want to make it more convenient, and you want to go for like 1 meter interval. So in that case, where you are getting that in that particular area rainfall, whatever the measurement is going, it is not in an accurate way, or some instruction that you need to change your base from that particular location to this location. So there is shifting of rain gauge may be there. Again, change in the ecosystem due to calamities. Sometimes what happens, suddenly landslide has took place and it has washed away, or it is taken over, sudden cloudburst is there, it has taken away your rain gauge. So what will happen? Your office may be vanished. So that time also that this ecosystem may be disturbed because of these natural calamities. Similarly, occurrence of observational error from a certain date. Let sometimes what happens that the person who has been assigned to collect the data, he was on leave for next 15 days. And he has not assigned anyone. Neither higher authority also has said that that particular person, in absence of him, will collect all the data. So what happens that you have not collected data for next 10 days, maybe 15 days during monsoon. So then problem will arise. So similarly, this is what I try to put it, that why that consistency you are not getting. Similarly, relevant when change in trend is more than 5 years, because after 5 years, whatever the change of the value you are getting because of the climatic change, because of the other factors, it is not coming as you have got 5 years back. So that time also that this consistency of the record may not be there. So I have shown you or I have said you the causes, but this causes itself is saying that why consistency of record is need to be tested. So next, test for consistency, as I said, the double mesh curve technique is there. It is one system that up to the year that whatever the value you are getting. So if I'm considering over the average accumulative precipitation of neighboring stations and accumulated precipitation of station X, so that way some sort of trend of changes has been taken place, and based on that we can go for that the PCX corrected precipitation at any time period T1, original recorded precipitation, the corrected slope in the double mass curve system, or original slope of the mass curve system. Why it is happening? Because actual curve should be this one, straight line, or maybe some sort of relation. The changes is there, but suddenly it has come up this direction. So this has happened in the double mass curve. So how to correct the old data? It is one system is called double mask curve technique. So design of again in the system generally in the two phases. One is hydrological analysis and another one is hydraulic analysis, hydrological and hydraulic. So in the hydrological analysis, the main objective of this analysis is to estimate the maximum quantity of water expected to reach the drainage system under consideration. So whatever the drainage system you are considering, so we have to analyze that how much water has reached to that place. Similarly, some portion of the rainwater gets evaporated and infiltrated, and the rest is called runoff, which flows over the surface. Let I'm considering that in a very hot day, suddenly you have got some sort of rainfall. Please do remember, since your surface bituminous in nature, so automatically top surface of the top surface of your flexible pavement temperature is very high. So if you are driving that period, suddenly you will find that whatever the rainwater is coming up, some sort of some particular the rainwater drops are evaporating immediately. Maybe you have seen that after some summer day or some hot day, if some raindrops are coming up, you will find some sort of vapor in the top surface of the your road. So this is nothing but the evaporation is taking place. Similarly, some sort of water may go directly to the ground surface. So whatever the surface water has water that pass to the surface road, those are considered about the surface the road. What this is what is called surface rainfall, maybe type of soil, topography, vegetation, etc. If there is vegetation, so rainfall, so the whatever the road, whatever the water is passing from higher land to the lower land in the surface. So due to the vegetation, it will not go down because vegetation will stop or obstruct it to go to the vertical. Similarly, topography maybe some sort of erosion there. So to counteract that or some sort of what is called slopy ground, maybe mass water you may collect or maybe some less water you may collect. So based on this topography, similarly type of soil, if it is questionless soil, automatically it will allow to go the water towards the down surface. Similarly, if the heavy rainfall is there, so in that case also that you will get more surface water or surface runoff. Details of the average intensity of the area for a selected frequency and duration equal to the time of concentration are also required. You know that how much average intensity of the area that you are getting the water. So all will help to get the analysis of that drainage system under this hydrological analysis. So from the data, the inlet time and the time for the flow of water from the farthest point to the drainage are calculated, which gives the time of concentration and the intensity of rainfall. So more and more longer places there where high ground is there and your side drains or you can the point where you are going for the drainage system is longer. I mean the distance is more. So what will happen uh, during the traveling time of the water from highland towards that your drainage system, some sort of water may percolate from the surface towards the nearby area. So as a result, you may not get the water that it has come in the farthest point and the point that you are collecting the data in. The drainage study contour map and topographical map is always helpful. The estimated maximum quantity of water calculated for now in the design of the drainage structure. The rational method useful for small, usually urban and watershed areas, which is less than 10 acres, or practitioners say it may less than 200 acres. So simple calculation: Q equal to CIA, where C is the runoff coefficient, I equal to intensity of rainfall, A is the cross drainage area, and Q is the runoff. And if I'm considering about the metric system, so it is the formula comes out easier because you have converted this fit FPS system to the SI system. So the formula will become 0.0028 CIA. So that another point that we need to consider about the runoff coefficient. This is called capital C, or in this case we are talking about. There are some methods of runoff estimation. For example, the rational method address the effect of catchment characteristics through the single coefficient of runoff P. The coefficient of runoff P for the given area is not constant, but depends on the porosity of the soil, vegetation cover, surface
ಹೇಳಿದ್ನಲ್ಲ
storage.
ಇದು ಮಾಡ್ಬೇಕಾಗಿತ್ತು ಇದು ಮಾಡಿದಲ್ವಾ ಮ್ಯೂಟ್ ಆಗಿತ್ತು
Uh, Sir Kamakshi, I mean, can you mute, please? Okay, next is the coefficient of runoff P for the given area is not constant but depends on the porosity of the soil, vegetation cover, surface storage, slope, initial soil moisture capacity, etc. Because these all C are dependent on whatever we have considered, the porosity of the soil, the type of soil available, then vegetation cover, then surface storage, because there will be some particular layer of the soil where already water is there. So again, this maybe there's some moisture content is already there. So all considered and depends on this C that the surface runoff or the runoff coefficient works on. The hydrologist engineer should decide on approximate value of P, runoff coefficient of runoff P, based on the experience judgment and the catchment character. That is the one important judgment it comes to you, because it depends on your own judgment also, most of the time or sometimes. The sum suggested value of P for use in national formula is given in the table, because what should be your value that you need to consider, like this one. Runoff coefficient 0 to 1 depend on land use and soil type. Sorry. Yes. So when watershed has many land uses and soil types, weighted average runoff maybe there C equal to C1A1 plus C2A2 CNAN divided by A. So ultimately you will get the average or more accurate value of C. So coefficient that represent a fraction of rainfall that becomes runoff depends on type of surface. Runoff coefficients are this one, and then description of the area is if it is the business area, the downtown areas, the neighborhood areas, residential, single single family areas, multi-unit trust, multi-unit trust, residential, then suburban. The value are given here. Industrial, light areas, heavy areas, parks, playgrounds, railroad, yard areas, and unimproved.
দৌৰিব নালাগে ইয়াক গোটেই ফেনৰ হাৱা খাই থাকে যে
আপনি এফআইএল সিগনেচার করে দেন
সব কৰি লৈছিল
কইলে
দৌৰিব নালাগে মোৰ ট্ৰেইনিং শেষে হোৱা নাই
Can you unmute, please? Sorry, mute, please, because there is some noises are coming up from Are Khan. All the participants, when you discuss about your office work or any work, please mute yourself. Otherwise, it disturbs the presentations. And some of the point that description of the area, I try to put it in the left side, and the runoff coefficient is this one. The runoff coefficient depends on what are the points that you need to, or that how it depends on that we have discussed noted, but once again I'm putting it in the point wise. Characteristic of soil, similarly shape of drainage area, antecedent moisture condition, because previous what are the moisture conditions are there. Then the slope of watershed, amount of impervious soil, land use, duration, intensity. These are the points that runoff coefficient depends on. I'll tell you one by one in the coming time. The type of drainage area that depend upon concrete or bituminous pavements 0.7 to 0.95, gravel and macadam surfaces 0.4 to 0.7, impervious soils with turf, slightly pervious. Just a minute, please. Sorry. Uh, uh, then we are considering right now runoff coefficient C here. The slightly previous soil C's value is less. So have a look on it. It's when the concrete bituminous pavement is where the impervious layer is there, near to the impervious layer, that time runoff coefficient is increasing. And if I'm considering a pervious soil with a slope, you say value has got increased. So what will I give the effect? Because C value will decrease. We know that Q equal to CIA. So automatically since CIA value is more, so Q runoff will be more. So now once again I'm repeating, you see, more pervious layer, more C value. So now if I'm considering about that equation that we are talking about, this one CIA, so C is more, so automatically runoff will be more because loss of water is less. If I'm considering a muddy surface or maybe a soil surface where C is minimum, so in that case Q value is also minimum. So it directly proportional to C. So that way I'm considering that it's a railroad yard or the unimprovised road, so all works this way. Okay, have a look on it. So runoff coefficient in case of urban, if it is strict, if it is asphaltic, the concrete, because this is the urban if I'm considering the cities. So drives and walks, then roofs, based on that you can have a look on these runoff coefficients. The lawns, flat, average steep, lawns, flat, average steep again, heavy soil, sandy soil. Heavy soil in the soil, in the sense of that the soil is having more bearing capacity, or good soil you can say, well graded soil. So here you will get that runoff coefficient C is in the higher side. So similarly, the determinant of the runoff coefficient for high intensity event, this is the runoff coefficient we compare to the inches per hour or maybe the water share or intensity of water. So based on that forest very pervious, you see that these graph are showing if you want to go for the C value and if you know that per hour water is there, so based on that you can determine the C value and that you can put this C value based on another one is the built up area or maybe at the south urban residential area, so suburban residential area. So there also you can find the C from this graph. So let I'm considering one where that is one is that C equal to 0.16 for low intensity event for cultivated field. Let I'm considering this is the cultivated field of area. And see we have got 0.16 for low intensity event for cultivated. Low intensity waterfall was very less, between 25 to 50. Similarly, if I am considering the high event where 150 millimeter or inches, which is on the higher side, 150 multiplied by 2.45, you can multiple. So you'll get the more and more water. So per hour. In that case, and if I'm considering that the same cultivated area is there, so in that case, C has got increased. So these from the same graph we can find out the value. So again, we are continuing with the intensity, average intensity for a selected frequency and duration over drainage area for entire duration of storm. Based on design event, that is 50-year storm, considered our design is costly, and then under design may be inadequate. So there are two mentioned here. Average intensity for a selected frequency and duration of water over drainage area. Then based on design event, I'm considering a 50-year storm, considered where our design is always costly because we have to think about the cost effectiveness also. Then under design may be inadequate. Duration is important because how much more duration, more water rainfall will be there, so more and more water will come up. So that's why duration is also important. And based on values of TC and TC is the time of considered and recurrence interval or design frequency. And this is another point that this intensity depends upon. So design event recurrence interval, 2-year interval, 10-year interval, 50-year interval, and 100-year interval. If I'm starting from the 2-year interval, design of intakes and spread of water on pavement for primary highways and city streets. Next is if I'm considering 10-year interval, design of intakes and spread of water on pavement for freeways and interstate highways. And 50-year considering about this one design of subways and sag vertical curves. Western sewer pipe is the only outlet. In case of 100-year interval, major storm check on all projects will come up. So time of concentration TC another important point that we need to consider. The time for water to flow from hydraulically most distant point in the watershed to the point of interest. Rational method assumes peak runoff rate occurs when rainfall intensity lasts, that more than the TC. Use the storm duration, because storm duration means that the particular duration where you are getting the maximum rainfall. Then depends on all this time of consideration, also depends on size and shape of drainage area, the type of surface, the slope of drainage area, rainfall intensity, whether flow is entirely overland or whether some is channelized. Because if it is overland, the possibility of loss is always there. But if it is channelized, so definitely your channel will be the concrete one, maybe bituminous one. So that way, whatever the water collection in the inlet, the same will be you are reaching in the outlet also. That's why it mentioned about that whether flow is entirely overland or whether some is channelized. So in the catchment area and the watershed area, how it is considered a combined area of all surfaces that drain to a given intake or culvert inlet. Determine boundaries of area that drain to same location. That is high points, mark boundary, or natural or human-made barriers. All comes up in this catchment area, because catchment area cannot be a confined area. But if there is particular location, is that if I'm considering in your office and your office has some confined area of that control of that particular area where whatever the water is coming out, rainfall is there, that all data or all record comes to your under you. So in that case, your catchment area is in that particular boundary up to where municipality boundary up to where you have the jurisdiction. Similarly, the other office of your colleagues may have the jurisdiction of the next area. So this area itself you can consider as a catchment area. So catchment area is in the mentioned way, that is delineation of catchment area is a very important step to estimate peak discharge, and it has a direct linkage with the flood peak, because in the particular catchment area how much water you have received or how much rainfall you have received, and whether that rainfall is creating flood in that area or not, all will be considered in that record. The flow from catchment area contributing to roadside drains comprises two parts. One is runoff from road surface, another one is runoff from adjacent land. Because whenever we are considering the drainage system, the water doesn't mean that water only will come from the surface of the road. It may come from the nearby area also, because both sides is open. So that way, there are two sections we need to consider. One is from the road surface, another is from the adjacent land. Then road surface runoff is from proposed road, depends on the width and camber of proposed road. For straight reaches, half the design width of road may be taken, whereas for super elevated reaches, full design width should be taken. Duly considered the proposed paved or unpaved portions in both cases. So adjacent lane runoff, because we are considering right now with the top surface only. Now we are considering about the nearby area. That is runoff from adjacent land depends on the topics of now. Sorry. So road surface runoff, I'm considering, sorry, I'm here because some, in between some sort of things has pop up. Annotation request is coming up, so I'm approving it. Let me talk with in the later on. Sorry. So now we are continuing about this is I could not understand why Nagarjun KM has annotated it. Can you stop this one?
Sir, sorry, sir.
Please, I am getting disturbed, man. Don't try to, R&D, research and development, because it is creating the problem. So it is thereby necessary to gather information on natural and man-made ridge lines running along the proposed road alignment, that these ridges should be considered as boundary for defining catchment area contributing to flow from the adjacent width, because we are talking about the adjacent land surface only. Guys, because of this annotation, I'm not able to uh, the process my presentation. There's some problem has been arise, so I'm repeating the whole presentation. And is a kind request to the participants, please don't do that. I have to go out from my presentation now. Very unfortunate. This is a humble request to all the participants, otherwise I have to stop my presentation. And organizing team, if someone is doing, sign to him. Are you able to? So it may be responsible because we are talking right now just and land runoff, and it may be to linearly of catchment increasing length of road and roadside edge, because it is under your jurisdiction. So each choice is yours. So whatever you want to do, because you can increase your catchment area also, and based on that authority that it has permit, okay, you can increase your catchment area because you are collecting the water run or surface runoff, and these will help you for the road drainage system. So that's why if you are increasing that length of catchment area, so it will also increase the length of road, because length of road is increased, so automatically catchment area has to be considered that way. And continuing adjustment will depend on the transverse slope of land. Transverse the proposed alignment, roadside drain on one side shall intercept the flow, whereas roadside drain in the other shall carry runoff from road surface only. Because as I said, to both the water, because main purpose of this drainage system is to collect the water from the surface of the road as well as the but sometimes since other side is also open, so nearby area water also can be collected. So that's why your drainage system should be such that it can carry both the loads, whether it is from the road surface or whether it is from the nearby area. Picking up spots levels to generate contour map of the area is the best option for delineating catchment area. However, this is not a realistic method due to prohibited cost is also there. That is why that physical survey sometimes it help you to make the contour maps where possibility of particular location all the water will come, but it is not may not be always possible sometimes based on the jurisdiction. So watershed area calculation, one is the topographic map, aerial photos, digital elevation models, drainage maps, and field reviews. These are the how to calculate the watershed area. So what is this one? This is nothing but a typical water direction of LIDAR, that is on remote sensing diagram for where I try to put some photograph from some websites only here. So one is being put it from LIDAR and another is put it by the USGS. But the main purpose of the area is same. But in the USGS International Geological Survey, you can have that they have divided more and more area based on their requirement. But in case of LIDAR, there is the directly taken from the satellite. It may not be the same. But our main purpose is to get the highway system of the drainage. I mean, drainage system of the next to the highway. So that way, how much catchment area for this system ladder is there, and whether you have to go for this system, it depends on the authority or depends upon your jurisdiction. Similarly, digital elevation model we are talking about that is readily obtained from structural rather topographical vision. That these data are freely available and very useful for delineating catchment. In our case, India Bhuvan website is there where you can get more and more maps in a particular area. Then Google Earth images, which is quite common, are very useful in delineating a small catchment area. The accuracy of manual delineation increases in rolling to hilly terrain. Special care is required for delineating very small catchment in flat terrains. Google Earth imageries are freely available and widely used these days. This is one important, and everyone can collect data. Next is topo sheets. Topo sheets of different skills are available from Survey of India. In India, we are having the group, the organization called Survey of India. These topo sheets also will be helpful to get this catchment area based on IRC SP 42 and 2014. And here it has been carefully marked about the ridge line between two contours of very large intervals, and which will help you the which catchment area you are need to consider and from where all the surface runoff will come for your design purposes. So hydraulic analysis, a simple equation Q equal to AB. I am sure that all of you have come across this. The velocity of water multiplied by the cross-sectional area of I mean the particular location. So these are drains or the cross-sectional area of this drain, and the culverts are now designed on the principles of flow of open channel. And as we know, as I said, Q is the quantity of water, meter cube per second, V is the velocity of water, and A is the cross-sectional or required area of the drain. The velocity is calculated using Manning's formula. All of you know, where R equal to P by A, the perimeter divided by cross-sectional area, and S is the slope. And N is the Manning's number, and based on some parameters, we can assume this N value. So as I said, N is the Manning's coefficient, and R equal to A by P. And minimum cross-sectional area is calculated from the permissible non-scouring velocity and the maximum ditches. And I'm sure all of you have come across these equations while you are reading the hydraulic engineering. So design of surface drain. So it is consist of the following steps. One is depth of the drainage trench. The depth of the trench at which the subsurface flow has to be intercepted is determined on the basis of impervious stratum level, soil type, and the requirement at which the subsurface flow has to be maintained. Then selection of the backfill filter material for the trench. The backfill's purpose is to improve the interception ability of the drain and to provide effective water collecting space adjacent to the pipe. Such materials should be coarse enough to allow water to have easy access to the pipe, but also should be fine enough to act as a filter material to prevent base soil from the intruding into the pipe. Because if this soil starts to intrude in the pipe, then it will soak. So I mean that it will clog up. As a result, no water will pass from high land to the lower land. As a result, flood. I mean that some sort of temporary flood will be there, and as a result, the main purpose of the drainage system will be vanished. So the size and number of perforations in the drain pipe is depend upon some of the points that should be able to intercept all the water entering the drain without causing a high head in the filter material. Similarly, hole should be sufficiently small enough to prevent the filter material from being washed into the pipe and the plug of the holes. And generally, maximum width of the slotted hole we consider as 0.83 multiplied by D85 filter, because it is the size of the filter, maximum size of the circular filter. So then diameter of the drainage pipe must also be considered, where the diameter of the pipe for a given length should be selected in such a way that the pipes will not run full near its outlet and flood the surrounding filter material. It must also be big enough so that all the intercepted water can be discharged through the pipe. Currently, no authoritative single recommendation is available. As I said, because here, whether this more specification or Ministry of or the IRC consideration, it is not there that how much size of the pipe is required, but it depends upon the particular surface water has been collected of that to get it. I mean, uh, get it out of all the water which has been poured up during the monsoon season. So but in practice, 150 diameter pipe are commonly used. The design of the initial abstraction must be considered, or you can say this way, that a part of the precipitation gets captured by levees of vegetable cover and trees, natural depressions, and smaller features in a watershed. This part called initial abstractions of the precipitation does not contribute to generate the peak, as this either gets evaporated or infiltrated or reaches out. Because such type of, as I said you earlier also, that whenever there is water collection is there, automatically water is not the filtered water. There are many foreign particles will come up, maybe some sort of grass or some sort of other so you may get that particular peak. You can't say that after 1 hour I'll get the peak or after 2 hours I'll get the peak. You may get within half an hour also. So other thing is there that whenever you are collecting the water, please do remember, since your area is very large enough, so nearby water also can be joined up in that surface water also can be joined up in the stage. So that is why all the consideration of the hydrological design is required under these initial observations. And some of the photographs I did put in some of the points that I tried to put some sort of foreign things. This type of obstruction of the water is always there. Similar, some water is coming up from this side, maybe nearby areas there. So this paver blocks is creating some sort of obstructions. And it has come directly to the surface. So these are some sort of initial obstructions. So that incident moisture condition also another point that we need to consider. Then of soil escape the relative wetness or dryness of a catchment before the design storm hits the area. Antecedent moisture condition can have a very significant effect on the flow responses. The antecedent moisture condition was grouped into 3 levels according to the total amount of rainfall in last 5 days before the design storm and is given below. One is in case of dry, normal, and wet. And dormant season and the growing season, all the values are there. Definitely, I'll share with the PDF so you will be able to see the data from here. So the hydrologist should suitably consider in the design the AMC based on the recorded rainfall for the last 5 days. Generally, this is the standard one we consider. In case records are not available, the rainfall distribution pattern of the area, the number of rainy days, season duration of the rainfall, even in general, should be studied in the selection of particular antecedent moisture condition of the hydrological design need to be considered. By this, I would like to wind up my presentation. So thank you very much. The teacher, when some presentation is going on and someone is creating some sort of problem, so it is always disturbs the presentation, the flow of the presentation. Thank you. Thanks a lot. So organizing team, are you there?
Yes, sir. Yes, sir.
And if you have any questions, please feel free to ask the questions.
Good afternoon, sir.
Yes, please.
Mr. Vinny Palan. I'm from Arunachal Pradesh.
Hi, Vinny.
Uh,
Yes, please.
Sir, actually, what we are facing in our state, mainly
Yes.
not only the catchment area,
Yeah.
but always we used to
Yes.
observe, especially in the monsoon period, the drainage, it is covered by the debris.
Yes.
The water comes with
Yes.
all the debris, sir.
Yes.
So it
Yes.
used to generate blockers. And moreover, sir, the DPR consultant, what they used to do, just they used to give the standard just the 45 by 60 or the 60 by 90, this size.
Yes. Yes. Yes.
Sir, you have rightly pointed out, I think during the preparation of DPR, they hardly consider about the
I agree, Vinny. Yeah, you are right. You are right. I really agree with you. Yes.
Sir, so what I would want to request you, sir, as a expert in particular this sir, subjects,
Yes.
it is my request, sir, ki through IIT or sir, yeah, or through the IRC forum, it
Yes.
can be suggested, especially in our hilly area,
J.
drainage should be properly designed.
Yes.
They should not allow to put the standard right.
Yes.
Just take the thumb rule, size 60 by 90 or 45 by
Yes.
60 like that. Sir. If it can be just implemented properly, and if you can give a suggestion, sir. to
Yes. Yes.
IRC
Thank you. Thank you.
Thank
Yes. Thank you, Betsy. Thanks for your request. Yes, definitely in the bigger forum, definitely I'll talk about it. You know, Betsy, I'm just sharing my own experiences. And I worked on behalf of Government of India under Ministry of External Affairs Foreign Service Protocol, 3 years in Bhutan. So from 2016 to 2019. And as you know, Bhutan scenario as well as Northeast India scenario are same, hilly areas. And the Bhutan's roads are maintained by Project Dantak of Border Road Organization of Government of India. So most of the roads are destroyed during the monsoon season and due to landslide, and it's quite common in the Punchiling Thimphu highway. It is the only big highway connecting rest of the world to main city of Bhutan. This is called Thimphu by road network. You know, after removing the debris of the what is called from the landslide, whatever the debris come up, still there are some foreign materials are always there. And if there is rainfall is there, automatically this rain water is carrying all the debris towards the drains. As a result, more and more temporary flushes comes up. So whatever you have suggested, definitely I am correlating with my own experiences the Bhutan, and I have got it exactly what you were trying to say in this forum. That you know, our higher authorities or our authorities are very clever, because if they are considering about any design prospectus, and if they do not want to use more and more money, because cost of thing is always there. So generally, in case of hilly areas, if there is road is there, you have to put one fencing next to the any drain, so that if any foreign materials are coming up in the form of thatch roof and the thatch, or in sort of bamboo leaves and all, it can be obstruct somehow and it can be maintained. You can remove it in a temporary way, foreign material free, and it can drain immediately whatever the drain has made for the purpose. So this is another point that if you have that authority, or if you can take up with this matter with your authority in immediately, where they can ready to spend some sort of netting system or fencing system next to the road, at least in the side where slope is in the very steep. So that way you can at least obstruct some sort of I mean that water logging or water blocking in that particular area. Thank you. Thanks a lot. And anyone else Definitely, I will share your presentation because I'm seeing because some of our participants has sharing their email ID, and please just to inform you that I will send this my presentation to the organizing team member, organizing team, and then they will share with your email because they have the list where all the email IDs are there, and hope it will be helpful. Thank you.
Okay, sir. Thank you very much for presenting the presentation as well as sharing your experience with the participants. I think that the participant will get the benefited from your lecture, sir, and try to implement all those things which they have learned during this session in their. So thank you very much, sir.
Thank you. Thanks a lot. Thanks a lot. Thanks a lot.
Thank you,
Please
sir.
share
Thank you.
Thank you. Thank you.
as soon as we receive from the faculty, sir. Okay. Thank you very much. Now, Neeraj ji, please finish the meeting.
जी सर